Hello all, welcome to our webinar Snowflake from Scratch from Data Ingestion to Dashboard Visualization. My name is Hassan and let me pose a few questions for you. Are you a firm that handles huge amount of data? On top of it, it is of structured, semi-structured or unstructured data type in its format. Are you concerned on selecting a tool which can perform transformation of this diverse data at scale? Or are you unable to figure out how to migrate your data? Or another potent scenario, are you someone who is worried about data security? So if all of these are your concerns, then we have a tool, Snowflake. So it is our go-to tool to address all above mentioned problems. We will have a series of webinars on this amazing tool solving different industrial pain points. So something about us. My name is Hassan Sherwani. I am working as head of data analytics practice at Royal Cyber. Something about my background. I hold a PhD degree in data analytics. I have been a para-academic for around 13 years. I have contributed to multiple projects in sectors like energy, automobile, retail, fintech, law, and telecom. Finally, I have gained hands-on experience in big data analytics and machine learning. I have with me my colleague Shamir. Shamir, go ahead, please.
Hi, everyone. Thank you all for joining us today in this exciting webinar. My name is Shamir. I'm a data engineer here at Royal Cyber. I hold a master's in data science with over 3 years of work experience. So as a data engineer here, I'm responsible for designing and implementing data solutions that are best suited to our customer needs. I'm also part of the team that's responsible for designing best practices to support continuous process of automation for data ingestion and data pipeline workflows.
Something about us, Royal Cyber. We are around 1800 plus member company, 10 plus location around the globe. We have very strong cloud practice, having around 250 cloud experts. Most of them are certified. We keep diverse cloud portfolio in terms of certifications such as AWS, GCP, Azure, and IBM. We have also a large open source practice where we work with open source tools such as Spark and Python to solve machine learning and data analytics problems where we can actually help you out. If you want to know more details, please shoot out an email to us and we'll love to tell you more about us and our services. So let me set agenda for this call. First, we will introduce Snowflake as a tool. Then we shall talk about its salient features, architecture where we have database storage, query processing, and finally cloud service layers. After introduction to architecture, we shall then explore data storage component for data engineering perspective. We then will shed some light on a radical paradigm shift in cloud and data engineering domain especially. Afterwards, we shall give you a fun demo and finally there will be a Q&A session. So brace yourself viewers as I give stage to my colleague Shamir.
Thank you, Hassan. So without further ado, let's get started. Snowflake is a cloud-based data warehouse solution. So it's not just a warehouse because it provides many services. So we cannot call it just a warehouse. So at the moment, there are only three cloud-based providers that currently support Snowflake. So namely AWS, Azure, and GCP. So if we talk about the features of Snowflake, it supports all sorts of data. So initially, Snowflake only supported structured and semi-structured data. But recently, they have come out with this new infrastructure called Snowpark, in which now Snowflake can process unstructured data as well. So I think it has the potential to be an alternative to Spark. So there is no infrastructure management. So you can be up and running with Snowflake in minutes. So virtual hardware and software is managed by Snowflake. So the next feature is data storage management. So it manages the data automatically, it compresses it, and it stores it in an optimized manner. So we don't need to worry about the storage of the data. The other feature is metadata management. So Snowflake collects statistics about the data automatically and stores it, which helps in query optimization. So we're going to talk about it in a later stage. So Snowflake also takes care of the manual query optimization because it performs clustering and partitioning on the data. So that makes the query performance and speed a bit better. And it caters all of the users, so it has the ability to cater as many users as possible without overloading the system. So for example, each department of the company can be assigned an independent virtual warehouse, and which will not affect the performance or speed of the other warehouse. So Snowflake follows a model of pay only for what you use. So you pay for only the resources that you use. And the last feature is live data sharing. So it provides us the feature of that we can share data live and securely, even with people who do not have a Snowflake account. Okay, so before digging into Snowflake's architecture, I think it's of paramount importance that we first understand shared disk architecture and shared nothing architecture, because Snowflake's architecture is a hybrid, so it takes a hybrid approach. So on the left-hand side, we have shared disk architecture, in which, so for example, Oracle uses the shared disk architecture. So in this architecture, the storage is shared by all the nodes in the cluster, or to be specific, it is shared by all the compute resources. But the problem with the shared architecture is that it has a single point failure, which means that if one thing goes down, it will fail the system. So another problem is that with intensive workloads, even if we add more nodes, the workloads will consume a significant share of bandwidth and will compete for the same resources, so which will in turn slow down the system. So another problem is that partitioning and load balancing are also very time consuming. So these are a few issues with shared disk architecture, and now we come on to shared nothing architecture. So in this architecture, for example, Teradata uses shared nothing architecture. So in this kind of architecture, data is partitioned across a set of nodes, and each node has a separate disk or storage, so it does not share any disk. So now the plus point here is that it doesn't have a single point of failure. So if one node fails, the other node can replace it. Another thing is that we can scale them horizontally by adding more clusters, but the problem is that compute and storage, they cannot scale independently. So since they are coupled, so scaling is extremely expensive here. Another problem is that, for example, there are two workloads, an ETL workload and an analytic workload. So loading and querying are very difficult to conduct simultaneously because it might choke the system. So for example, people who have worked on Teradata would know that that concurrent loading and querying is not possible. So loading usually happens at idle times. So now Snowflake architecture. So it's a multi-cluster shared data architecture. So it's a combination of both these architectures. So it is a hybrid architecture in a sense that it is similar to shared disk because it uses a central data repository that is accessible to all the nodes. And it's similar to shared nothing architecture in a sense that it uses massive parallel processing where each node stores a portion of the data. So the biggest feature of Snowflake and what makes it really special is that storage and compute are not coupled. So they're separate. So we can scale them independently according to our needs, and this thing reduces the cost. So the way it solves the issue of concurrent loading and querying that Teradata has is that each workload can be assigned an independent cluster, so with that doesn't impact the performance of the other clusters. So we can, since compute and storage, they are decoupled, so we can scale them independently according to our needs. And for example, one department of data scientists, they have been assigned a virtual warehouse, and they want it to because maybe they need more storage or maybe they need more computing power, so they can manage it independently. And another team that has been assigned another virtual warehouse, they cannot impact the performance of each other. So the system can never choke. Okay, so Snowflake architecture, it has 3 layers. So the bottom layer is the data storage layer. So all the data of Snowflake is stored in this layer. So since Snowflake is a cloud service, so the storage might be AWS, or it might be Azure Blob storage, or it might be GCP storage. The next layer is query processing layer, which is also called a compute layer. So in this layer, queries are executed using virtual warehouses. So these virtual warehouses are not the traditional or conventional warehouses that store data. These virtual warehouses are compute clusters. So each warehouse is a compute cluster. So the third layer is the cloud services layer. So this layer helps the compute layer to communicate with the storage. So it provides infrastructure management, access control, metadata management, and so on. So cloud services layer is technically the brain of Snowflake. Okay, so since I have mentioned that Snowflake provides many solutions, provides many services and solutions. So let's say that each team or each department has been assigned a virtual warehouse, or let me call it a cluster. So for example, data scientists can connect with Spark and do their data processing, and data engineers can connect with Matillion and do their ELT or ETL. And marketing people can connect, and finance people can also connect. So all these people's virtual warehouses cannot impact or influence each other's performance or speed because they are independent clusters. Okay, so what makes Snowflake unique is the way it stores data. So when data is loaded in Snowflake, 2 things happen. First, it converts the data in a columnar format, and it breaks the data in micro partitions. So, and second, it compresses it automatically. So it's a column-oriented database. It's not a row-oriented database. So which means that the data is stored in columns instead of the rows. So as compared to row-oriented data, a column-oriented data is faster and it uses fewer resources. So, and each micropartition is 50 MB to 500 MB in size. So so one might ask that can Snowflake support OLTP? So the answer is yes, it can, but it's not the best solution out there. And one reason might be that if we think about it, in OLTP, we perform CRUD operations. So in CRUD operations, we try to retrieve the data in rows. So that is why OLTP databases, they have their data is stored in rows. But Snowflake is meant for OLAP. That is why. So in OLAP, we try to retrieve the data in columns. So that is why the query gets optimized, and so a Snowflake is more meant for OLAP operations than for OLTP. So if we take a look at the picture, on the left-hand side, we have a traditional structured table. And on the right-hand side, after it gets uploaded in Snowflake, it makes the first micropartition. So the data is stored in columns. So, and if the data is really huge, we can, or Snowflake automatically can assign a clustering key to it. And so clustering is kind of that, for example, in this column, PS supply key. So the objective of the clustering is that same data resides in one partition. So if we think about it, when we try to query the data or some information, clustering makes it possible for Snowflake to not waste time scanning other partitions. So it will immediately go into that partition, and it can retrieve the data for us. Sometimes, so clustering is not necessary, but clustering happens just for query optimization. Okay, so now we can take a look at how things changed, and we moved from Teradata to a cloud-based data warehouse. So if we use Teradata, it's like I would say that it's like buying a car in terms of the cost. So if we are using Redshift, it's like renting a car, and when we use Snowflake, it's like paying per trip. So it means that using Snowflake is quite economical than using the other data warehouses. So there are a lot of, not a lot, but a few differences between Redshift and Snowflake, because at the moment, Redshift is Snowflake's competitor. So for example, in Redshift, the compute and storage are combined. They were combined, but I've heard that the new version of Redshift, they have separate compute and storage. So so another difference is that when JSON is loaded in Redshift, so it's very difficult to query the data and work with it. And on the contrary, in Snowflake, to work with JSON, it's a bit easier because of its native functions. Another thing is that is missing in Redshift is that it doesn't provide automatic compression. So Snowflake can also be used as a data lake and data mart because you can dump all of the data, whether it's structured, semi-structured, or unstructured. Okay, so now let's go through a demo on Snowflake GUI. Okay, so a little bit of the background on the story that we'll be working with a bike sharing data set that contains details about the trips that people took. So we'll be using a weather data set as well. We are going to do some data transformation, draw a few insights from the data, and in the end, we'll connect Snowflake to Power BI so that we could visualize the drawn results. So the data, this data sharing is live. So whatever changes that happen within Snowflake, they're going to be reflected in Power BI. Okay, so this is the Snowflake UI. So we are gonna, we can start from the warehouses. So up on the ribbon, we have this icon of warehouses. So these are the columns. So all the parameters of warehouses. So right now, I have created 2 warehouses. Their status is suspended. Their size is medium or small. So we have the option to choose the size of the warehouse. We can choose the clusters as well, minimum and maximum. So they're not queued or they're not running, and scaling policy is standard. So auto suspend. So it means that analytics _WH warehouse will suspend after 5 minutes of not being used, and this after 10 minutes, and they will resume automatically. It's a yes, and this is the owner of the account. So Snowflake follows a hierarchy here. So we can also create a warehouse. So here we can define the name, and Snowflake gives us the sizes of these data warehouses. These are like t-shirt sizes. So extra small, small, medium, and so on. So so it costs us 1 credit per hour, which means that 1 credit in the standard edition of Snowflake is round about $2.6 per hour. So if we so Snowflake charges per minute. So if we convert it in minutes, so it's around, I think it's about 0 point something cents per minute. So that's very economical. Then we have the option of choosing the maximum cluster size and minimum cluster size. Then scaling policy and auto suspend. I'm not creating since I've already created. And if we choose a warehouse, we can also configure it. We can edit it. We can drop it as well. We can transfer its ownership. We can resume it as well. Now we go on to the databases. So these are all the databases. A few of them I have created, and a few of them are already built in Snowflake. So from here, we can create a new database as well. We can clone it. We can drop it as well. So if I choose weather database, here I can create a new table. I can load the data from here as well. I can drop it as well. Okay, so here are all the views that Snowflake has created, or we can also create. So the 2 important prerequisites for loading the data in Snowflake are stage and file formats. So a stage is sort of a location, not real location, but staging, it's a staging area. It's the same that we used to have in a traditional ETL thing, data warehouse, that from the source, the data goes into a staging area, and from staging area it goes to the destination. So first we need to create a stage. So here we can choose that what staging area we need. So for example, I can choose Amazon S3, and here I can name the stage, and here I can give the URL from where the data would be fetched, and the stage can be created. Another important thing is file formatting. So file format is the way your data will be structured when it arrives or when it is loaded in Snowflake. So for example, we can create a file format. I can name it whatever I want. Schema is public. Now file format. So now Snowflake gives us the option to choose all these file formats. I can choose JSON, Avro, Parquet, XML. Then compression method usually is auto. Then column separator, you can choose the row separator. And then these are all the options to ensure the successful loading of the data. Okay, so the next icon is shares. So here we can share data with colleagues. We can also share with people who don't have a Snowflake account. And this is the marketplace. We can get hold of nice data sets here. So this is the most important icon. This is the worksheet. So this is where we write all our code. This is another important icon, that is the history. So that is a very nice feature of Snowflake, because here we can get hold. So we can go back in time and see that which queries did we execute and at what time. So this is the query ID. This is the query that we ran. Who is the user, and what was the warehouse, and then how long did the query take to get executed. So that's a very handy information that we have. So for example, if someone has made a mistake, so one can always go in this history and find out that where did and who made that mistake. In this section, in this account, I can see that how many credits I have used, and which warehouse has conceived how many credits, spent how many credits. And then there's billing and users, so that's a very deep thing. So this icon is the Partner Connect. So Snowflake gives us the option to connect with Snowflake partners. We can create trial accounts here and see that which third-party service works best for us. And okay, so we can go back here, and here these four things are extremely important. So this specifies the role. So account admin, it can be sysadmin, or there are other roles as well. This is the name of the warehouse. This is the database, and this is the schema. So we can walk through the code. So first, it's very important that you know that what's your role and warehouse and database and schema, because sometimes Sometimes you have you have created a table or a database, and after some time you try to query that data from that table or a database, and all of a sudden an error comes that this database doesn't exist. So the first rule of troubleshooting is that you need to look at your role, because maybe you created that database or table when you were your role was sysadmin. So if you had created that database using the other role, so the other role person cannot be, so it won't be visible to that. Okay, so here the first step is that I made sure that I am in the right location. Then I created a new table called trips. The next step, as I mentioned before, that is to create a stage. So there are always two ways to do things in Snowflake. You can either use the wizard here, or you can write a code to do this. So I wrote a code to create this stage. So I got this data from AWS S3 bucket, city bike trips. The next step is to create a file format. So I named it CSV, compression auto, field delimiters, a few of the necessary parameters. The third step is to load the data in the table. So we can use the copy into command to load the table, and we must specify the name of the file format. So for example, I was having an error while loading the data. So it's Snowflake's documentation is very handy and very informative. So I found this option that on error equals skip file. So it can, so whatever files are giving the error, it won't upload them. The next step is that I created a new warehouse for the analytics team. So I named that warehouse analytics _ WH. Auto suspend. So this time I chose the size medium, and auto suspend is 300 seconds, which means just 5 minutes. It's going to stop working after 5 minutes. And then I made sure that I'm in the right location, and we can take a look at a few rows. So this is the data of the trips. So trip duration, start time, stop time, start station, and so on. Okay, so now we are gonna get some information from the data. We're gonna draw a few insights. So I'm gonna use a Dre trunk function, and then we are gonna find out trip duration in minutes, and then we're gonna use this function to find out the average distance. And then after this, I found out that when did the most trips occur. So we can run this query. So we can see that in the month of June, most of the trips were occurred, and then in September and October and August and so on. Okay, the another very important concept in Snowflake is zero copy cloning. So it means that if we want to copy a database or a table, so when we make a clone of that, it's not gonna copy that in real, but it's just gonna take a snapshot of that data, and Snowflake is not gonna charge you for that. So that's a very nice feature of Snowflake. So I created a clone called a trips dev clone trips. So trips def is the cloned table here. Now we will work with some semi-structured data. So we are going to use the data set weather data. So I created another database called weather and made sure the right place. I can run it. Okay. So I created a new table, JSON weather data. And so whenever we are working with JSON, Snowflake has a very special data type called variant. So this is something that we need to specify all the time whenever we are trying to load JSON data. So the next thing is to create a stage. So yeah, and then a file format. So the type is JSON, and these are the parameters. And now I copied JSON data in the file. So I loaded the data, and these are a few records. So here. Okay, the next thing I did is I created a view. So I kind of parsed the JSON data. I flattened it. It's not very difficult in JSON because it uses native. Snowflake uses native functions to flatten JSON data here. And here we can take a look at a few records. So we can see here that JSON has been parsed successfully. Okay, so here I just wanted to find out if there is any relationship between the two sorts of data, so weather and trips. So let's see. Okay, so yeah, there is a clear relationship. So in clear weather, the number of trips are higher than in cloud and then in rain. Okay, another handy feature of Snowflake is the concept of caching. So if whenever I run a query, it gives me the result immediately. And the reason is that Snowflake, whenever we execute a query, Snowflake stores its result. So the way how it works is that when you write a query and execute it, Snowflake finds and scans if this query was executed before. So if it was, then it gives you the result immediately. It doesn't scan all the files, and Snowflake doesn't charge you for that. So that's a handy feature. Another important feature is time travel and fail-safe feature. So time travel means that you can go back in time and correct your mistake. So for example, if I have accidentally drop this JSON weather data table, what I can do is I can undrop it. Yeah, so I have the table back, it's restored. Another, so it's not just only dropping the table, so it's also that if you have let's say if you have updated or one of your colleagues has accidentally updated something or changed something. So for example, I checked it, I set it as oops, and so I was able to restore the original data. So the other technique to rectify your mistake and get back the original data is that using the offset function. So it's minus 60 times 1. So it means that 60 seconds times 1. So it's 1 minute. So it means that whatever, if I run this, so it means that whatever the status of my data was 1 minute before, that status will be restored. And then you can, of course, increase the minutes. The third method of time travel is this, that let's say that if you have made a mistake and you don't remember that before how many minutes or how many hours or at what time did you make that mistake, you can go in the history, you can find that query that made the changes in the data. You can copy this query ID and you can run this, and then you can go back, you can restore the data that was before you executed this query. Okay, so I connected this with Power BI, so don't mind the look of this these graphs, but the objective was not to make a dashboard on Power BI. The objective was just to show that how we can connect Snowflake with Power BI. So these are just a few graphs that I made. So we can see that, so it's the data sharing here is live. So whatever changes we make over there in Snowflake, they will automatically be reflected here. So we have both these tables.
Thanks, Shamir. This was a wonderful session and an amazing demo. I myself learned a lot about Snowflake. For our viewers, we have an exclusive offer. If you wish to migrate to Snowflake or already are working with a tool like Snowflake, and you would like to have a consultation regarding it, then we have a jumpstart call free of cost, where we shall understand your business requirement, do a gap analysis, and would recommend a tailored solution for your problem. And now we shall take questions from our audience.